Well, hey there, everybody. We are on August 8th evening edition of the SkyTour LiveStream, starting now. We're coming to you from the John Zach Memorial Observatory in northwestern Connecticut. How are you all? Good to see you here. Tonight we're going to explore the beauty and mystery of the universe, as always, and it's going to be from double stars in the endless cosmic dance to star clusters from 10 to 10,000. We'll see it all, and it'll be live and uncut. As usual, if you've got anything you want to see, there is a full moon out, but we can try it anyway. Let's see what happens. Anyway, the telescope is acclimatizing, and we'll be right back to get going. Hey guys, how are you tonight? Mark here from the SkyTour LiveStream at the JZM Observatory. Listen, we still have construction going on, so throughout the evening you're probably going to hear, cars going up and down the road again, and motorcycles, and because it's a long, quiet road, people are going to go racing probably, so we'll have to put up with that. I apologize for that. Anyway, tonight, we're going to be doing the double star tour, and we're going to also be looking at some star clusters. We're doing that because, well, the moon is out, and the moon has a very bright aura around it that's making it hard to see anything faint. That's typical, actually. And when we look at the sky, we notice that when we look around the moon, especially when it's higher in the sky, the moon actually has it creates a blue tinge around it. And if you think about it, you say, well, is that blue tinge related to the blue sky we see? And the answer is yes. Ta-da, you win. Ding, ding, ding. That blue sky that we see during the day is created by something called Rayleigh scattering. Now, all that means is that when the sunlight hits the atmosphere, the atoms in the atmosphere and the molecules in the atmosphere will absorb just enough of that light and scatter it back out. and it scatters the blue light back, and it scatters it in all directions. So everywhere you look, you see a blue sky. Now, it doesn't scatter the red light, or the yellow, or the orange, or the green. It only scatters the blue, and that's because of a particular idiosyncrasy, I like that word, with nitrogen and oxygen molecules in the atmosphere. That said, when we actually look at the night sky, we also see that there is some scattering going on because of the reflected moonlight, which is also reflected sunlight, of course. So that's why the sky looks blue even at night. And if you take a long exposure with your telescope with a moonlit night, you will actually see a blue sky as well. So I think that this particular cut of music, it's called Almost an F Tranquility, and it's very appropriate for this particular double star system we're looking at right here. We're looking at a favorite of mine, and if not a favorite of yours, soon to be a favorite of yours. This double star system is called Albireo, and those of you who are looking at it going, oh, I remember this, we've talked about it, and we have indeed. And the nice thing is, okay, Albireo is really a very interesting system. Okay, it's in Cygnus the Swan. In fact, it's the head of Cygnus the Swan. Okay, and it's right in the middle of the summer Milky Way. And Albireo and its partner, the two components of Albireo, are in a cosmic dance. And this cosmic dance is going to take them around each other, and they are separated by about 4,250 astronomical units. Now, they're separated by 34.7 arc seconds in the sky, and I could give you the calculation that you remember once we talked about, and you can figure out how far away it is, but I'm going to save you the trouble. They're 400 light years away, and still, you have to wonder, those stars have to be really bright to be able to be seen from that distance, and the truth is, stars have this intrinsic property that they actually produce this fusion energy, the energy from fusion, I should say, and when they do that, the energy they give off is blinding, and that's something that we are trying to learn and emulate, because it's important for us to be able to do that. Now, it'll be an energy source that's unlimited for us if we can manage to do that, and it'll be an energy source that is safe and clean. Fusion is sort of like a reaction that I liken to being on top of a mountain, the very tippity top of a mountain at a point. At the very point of that mountain, you've got this fusion reaction going on. All right, that fusion reaction that you have is something that is it is something that you would find to be hard to manage, hard to maintain. So that said, if you get it wrong, even in a slight amount, then what will happen is that fusion reaction will shut down. Now, not so with fission. Okay, fission. Fission is what we use now with our nuclear reactors. And that's a spontaneous reaction that's always occurring, and we can only mitigate it, we can only attenuate it, that is, shut it down by adding these control rods in between these fuel rods in the nuclear reactor core. Not so with a star. If a star is unbalanced, the reaction shuts down. Same thing with a reactor if we had a fusion reactor. If it's unbalanced, the reaction will simply shut down. Now, with fission, if it's unbalanced, it can run away, and the reactor, if it can't be shut down with these control rods, then we end up with what we know as a meltdown. The same type of thing happened at Fukushima, because the tsunami blocked the air inlets of all the diesel generators, which were supposed to be the standby power, to control, guess what? The control rods to shut down the reactors. And that caused the reactors to melt down. And they lost 2 reactors at Fukushima. And they also poisoned tens of thousands of square miles around Fukushima with radioactive pollutants. That said, with fusion we don't have that problem. The worst byproduct of fusion is tritium. And tritium is an interesting little powder You're breathing it right now. There's trace elements in the air all the time, and it doesn't accumulate in your tissue. So you can actually accumulate, tritium for a day or two, and then boom, you'll get rid of it in the next few weeks or whatever. All right. So tritium is also has a property where if you had powder, tritium powder in your hand, you'd be just fine. You could rub it on your skin all you want, and it will not penetrate. The only way you get tritium in your system is through the water or if you inhale it. And then again, it's not accumulating in any kind of damaging way. Whereas in fission reactors, a gram of plutonium can kill 1,000 people. So that's terrible. So we're heading for fusion. That is the power of the stars, like Albireo A and B we see here. If you notice, on the right in the Albireo pair, we have this orange-looking star. And I don't know if you remember when we've talked about this before, but do you remember what kind of star that is? All right, it's a K-type star, a class K3. Okay, spectral class K3, and it's a stable, normal. It's a stable. Well, I should say a stable, normal helium fusing giant. So a stable hydrogen fusing dwarf is a star like the Sun. I know that's confusing, but that K3 giant is not on what we call the main sequence. It's not doing the hydrogen to helium fusing like our Sun is doing. Okay. Now, the star to its left is a normal dwarf star like our Sun. It's a normal main sequence fusing hydrogen to helium, and it's a B8. Remember the OBAFGKM. And Amanda's listening in, and I know that she will come on and tell you what that stands for. Amanda?
Oh, be a fine guy, kiss me.
Yeah, or be a fine girl, kiss me. It depends on whether you're, a guy or a girl, somehow, and maybe not. I mean, we're a little bit more relaxed with it. Yeah, it's a personal preference, yes. So it's an interesting thing. And by the way, thanks for joining me, Amanda. It's nice.
Hey all.
Nice to hear you. And we're going to be touring a lot of double stars tonight if we can, as long as the weather holds. We have a nice clear area right now, so we're gonna do what we can. And I like starting with Albireo because this is just a beautiful, beautiful star system, orange and blue, and depending on how your eye works, you might see them as yellow and green. When I was a kid, Albireo was an orange and green star, orange and green pair, and it was just stunning because it was such an emerald green. It was amazing, but it's actually a B8. So the color receptors in my eyes, as they aged and as they matured, I could see the blue more easily, and you can actually see the blue very clearly here, and the orange. Now, if we do our little defocus technique, which I'll do for you, just for fun, I can show you. Okay, as I do this, well, now it's clear. Okay, you can actually see the orange K3 giant, and you see the B8. Now, you know from what we're talking about that the O stars are really the bluest. Okay, B stars are less blue and heading more toward the white, and that's what this star is. If you saw an O star here, it would look very different. It would be a little bit more saturated blue color. So we'll bring that back now. So when we look at these stars, and we think, wow, they're 400 light years away, and they're separated by over 4,000 astronomical units. That's interesting, right? Because Neptune is 30 astronomical units away. Neptune, right? So that's incredible when you think about that. That these stars, our entire solar system, and more than some, the Kuiper belt would fit within those two stars easily. If we were around the B8 star, we would have a very bright star in our sky, that K3 giant, but we would also have an entire solar system that effectively would have some type of effect on it due to the K3 giant, but not sure what that would be. We'd have to do that, and we will actually investigate that when we do the rainy night streams, which I have already gone through and run through, we're going to be using a simulator to actually show you different aspects of our own solar system, other star systems, and you'll be able to literally request, can you fling Jupiter at the Earth, or can you fling the Earth at Mars? What would happen if Mars hit the Earth, you know? And we can actually do that right there on the spot. So this is going to be a fun simulator excursion on the rainy nights. So we can still have a SkyTour live stream even in the rain, and that's going to be fun. So that said, let's just take a look here at Alberio for a couple more minutes while I look for our next targets.
See, and I was going to ask about that actually.
Yeah.
You were saying that it's very unusual to see green objects. You were saying this used to be green and now it's going more blue.
Well, that's only because my eyes as a kid, the color receptors were seeing the blue as green. So a little bit of color blindness, and my eyes shifted when I got older. So that's the only reason. You follow?
So, okay, well, because I mean, I'm seeing it as blue as well.
Yes.
I mean, if I showed a young child, like maybe like a 4-year-old, would they actually see it as green?
I don't know. It depends whether they have that same color shift. I mean, I was just a little bit colorblind as a kid, and so green and blue kind of looked the same to me when I was a younger kid. But as I aged, the blue really became my favorite color, in fact, and then I ended up seeing blue for what it was and not as green. And the difference, see, colorblind people can see, in most cases actually, they can see the primary colors very clearly. It's the hues between them, you know, a bluish green versus a reddish blue. They may not be able to see the hues, for instance, and there's going to be problems with that. That's why when you get the eye test at the eye doctor, they show you that book with all the little dots and the colors in there. They're not primary colors, are they? They're actually pastel colors. They're colors meant to gauge whether you're having difficulty seeing the hues that are, you know, H-U-E-S, you know, the hues between them. And that's something that is really interesting, but I don't know.
Well, no, because I remember on another stream.
Yeah.
And I can't remember what the answer was, but for some reason I remember you saying that green seemed to be a very infrequent occurrence when looking at, like, I don't know if it was globular clusters, maybe? I don't know, but it was some, like, we could see the occasional red, we could see from time to time blue, but you said green. Now, is that just because you don't see them because of your eyes?
No.
Does it have to do with the eyes, or is it just an occurrence, and if so, why? Because I don't remember that part.
There are stars that have green light, but the thing is, it's so close, okay, to the yellow side and the blue side that they tend to be either yellow or blue, and only if they're really at that direct separation point between yellow and blue do you actually see it. All right, but it's a fairly sharp delineation. Whereas going from an orange star into a red star, all right, it's a fairly gradual range. You see orange and then you see a sort of red. But when you go from yellow into green and then into blue, it's actually fairly steep there, and maybe that's just a property of the stars in the universe. But there's really very few emerald green stars out there, actually.
Yeah, that's what I was wondering why.
Well, let's take a look at another double. I'm gonna take us to another little spot, which is right overhead almost, actually. I'm gonna pop this. You can see that one last second. And it's Alberio.
Hi, Alberio.
And we'll say goodnight to Alberio tonight, and let's go to...
Can we see Antares in Scorpius?
Yep, that's visible.
Okay, because Daryl's saying that has a secondary that is sometimes described as greenish. Is it a contrast effect?
No. Again, there are stars that are green. And
okay, so it's just one of them. Okay, cool.
And we're actually sort of in the area of Antares a little bit here, not quite. But
well, I know it has to be more doubles tonight because of the moon.
Oh yeah,
but
the Fantaris has a
if
double.
we can see it, yeah,
we're in the area. We'll check it out. Yeah.
That's so cool to say. Oh, we're in the area.
Yeah, right.
We'll
we're
just
in the
drop
area.
by.
We'll just drop by.
That's
folks.
cool.
So this is a star called Marsic, and it's actually in terms of the Greek alphabet, it's the star that's Kappa, Alpha, Beta, Gamma, Delta, Epsilon, Zeta, Eta, Theta, Iota, Kappa, Lambda. You know, it's down the list. It's a lesser bright star in Hercules, the constellation Hercules, which is where the Great Cluster is, the Great Globular Cluster. And when we look at this, okay, we actually see, and let me just get us closer, and I gotta get up now, and I shall go bring us into a little magnification here. Yes. I'll move us over, don't worry. Now this double, okay, if you take a look at this double, check out those colors. You can actually see these pretty well. You know, this is this double star is a star that's actually separated by 27 arc seconds. All right, and it's just about 370 light years from the Earth. All right, and the stars are separated by just about 3,040 AU, astronomical units. So a little bit less than Albireo, but very cool nonetheless. And if we take a look, okay, the brighter star that you're seeing here is actually a magnitude 5 star, the bottom one. All right, now it's a class G star. The Sun is a G2. Well, this one's a G8, but there's a little difference. It's a G8, not a V or 5, you know, Roman numeral 5 like our Sun. It's a G8 3, you know, triple I. And that's a giant star. And the other one that you're looking at right there is the smaller star is actually a star that's a class K1, okay, all right, K1, but it's also a class 3 giant as well. So these are two giant stars. So what's really funny is that you can actually see I think it's a little loud here. Let me just drop this just a bit. Okay. Well, maybe not. It just faded away. Okay. Anyway, these are both giant stars, and it's really cool to see these giant stars just sitting out there. Again, they're 370 light years away, and one is a K3 giant, and sorry, K1 giant, and the other one is a G8 giant. Okay, and the bottom one's the G8. All right. So
are there?
Yeah, go ahead.
Sorry. Are there any double stars that are both the same letter? Like, is there a K1 and a K3, or a A1 and an A5, or a... Like, it always seems to be like a K and a G, or a K and a B, or something.
Yeah, Epsilon Lyra, okay, is actually the double, remember, in Lyra. And we may poke our head over at that one as well, but it's almost directly overhead. And it's a double. So those two stars in each of the pair, okay, there's a pair and then another pair, and then they all go around each other. You know, the two pairs go around each other while circling amongst themselves too. So it's like, wee! That's one heck of a complicated geometry and physics going on in that system.
It's kind of like the scrambler at a fairground.
That's funny.
At a midway.
Yeah, that's cool. That could be. Now, here's something though that I want to just mention about this. These two stars, okay? These two stars have an issue, okay? And that is the stars themselves are actually different ages. And that's something about binary stars that you learn, and that is that binary stars typically have the same age, you know, within a very small amount. These stars are very different ages. So what does that mean? Now, I don't know if anyone in the chat can figure that out. But
What's the question? How
the
can
que-
they be different ages, or?
no, how can they be binary stars, but have different ages? Does anybody know? Can they think about what that is? Because remember, binary stars form together. And if these stars didn't form together, what's that tell you about these stars? You know, and as I said, they're separated by 3040 AU. So you wonder, like, what is going on here? And that's the question that I have for the chat. What's going on here? And I can tell you later on if we don't get anybody to answer.
I don't know if this is going to be phrased properly or not.
Well, they're hearing me say it anyway, so.
I know.
The question is, these stars are very different ages. So what does that mean for their binary status? Does it mean anything? How can we have a binary star system with stars that are different ages when we know that they form together out of the same stellar nebula that they form from?
Okay, we have a guess, but there's a few people in chat, so we'll see if...
Okay.
May as well give a little shout out while we wait. Hi to Daryl. Heidi just went to bed if she's still listening. Good night. Thanks for dropping by. Tina's in. John is in. Duplicate was in.
Awesome.
There's 18 watching, but only a few commenting. So please don't be shy, guys. Any questions? Sherry, of course, is in here.
Mm-hmm. Hi, Sherry.
If there's anything that we may be able to see, try to keep it to double stars because the moon is causing a bit of an issue.
And clusters, globular clusters and regular clusters, we can see those.
Clusters, yeah.
Now, yeah, so...
did one draw mass from the other?
No,
No,
they're different ages, and that won't age the star or send it backwards in time to make it younger. So...
And Tina, I think, is it hello to Tina? Okay, well.
Okay, well, we
Oh, Sherry came up with a really good guess. Okay. It's like twins who were born a few minutes apart.
She's on the right track, but these stars weren't ever together.
Because it's... Okay, John's adding... One had less mass, so it took longer to start fusion.
Good guess, but sorry.
See, that's what I was thinking with those guesses. Yeah,
see,
just
I'm so glad
one somehow appeared before the others.
Yeah.
Some kind of fusion went off.
I'm really proud of you guys in chat, by the way, because you're not saying dumb things. You're actually making real lucid commentary, and I'm loving this. This is fantastic. You guys are good.
Okay, no, more people are entering. A whole bunch more people just showed up. Maybe it was roll call. Maybe they wanted to hear their names. Okay. David, Ian, Rockstar just showed up.
Hey guys, how you doing?
So again, the question is, this double star that we're looking at, they are two different ages. Each star are a different age. How can that be, and what does that mean to their binary system?
Very good.
Is that right?
It's correct.
Okay.
And the only thing I'll add is that it means something because binary stars, we know as astronomers that binary stars do form together. So how can these stars be a binary system and have different ages? Guess it's like a puzzle for gish wishes or something, right? Yeah. And while they're thinking about that, Amanda, why don't you tell people what gish wishes is, because you turned me onto it yesterday. And I thought it was an extremely worthwhile endeavor. Just if you can give I don't know if you got a 2-minute summary, but try your best.
Well, I mean, some people may have already heard me talk about this on other streams and stuff. It's the greatest internet scavenger hunt the world has ever seen. It's all for charity. It's all nonprofit. Each player donates $20. I think it was like almost 30 actually for me Canadian, but all that money goes to either, I think one year we built like orphanages and hospitals and stuff in Haiti. Went to New Orleans Relief a few years ago. They'll, buy shoes and computers for homeless families, or not homeless families, but like single families, or they'll go out and donate food and clothes to a local shelter, things like that. So the list got released Saturday. I'm going to be a lot more mental than usual this week. So yeah. And one of the items, there were 198 items we had to do. Each team has 15 people. There are at least 500 teams. This is worldwide. It's 1 week.
Well, give them an example of like what an object is. What is something, a task that they have to do?
Yeah, the items are either pictures or videos. And a few of them I figured Mark could help me with. One of them was we had to get pictures or videos of the 3000th Spectral Olympics.
And that means whatever it means to you.
That is what you have to produce. So take that as you want it. And I thought, how convenient. Mark happened to be taking spectral images last week, so I was like, can I borrow some pictures? And kind of played around with some ideas. Oh, it's going to be brilliant. I can't publicly release them until next week, because people will look for videos and pictures online to get ideas. But one, I haven't done it yet. I'm going to probably do it tonight. I have to get an official Zillow listing for a property on Mars.
And as I pointed out,
I didn't know what Zillow was, but how many listings did you find? Mark's like, you can't get a listing for Mars. Are you kidding me? It's an official, like, property realtor selling place.
Right.
And I'm like, it's Gishwish. Yes, you can. He's like, no, that's probably illegal. That's mental. And then he looked it up. How many listings?
I found a sell your home pick, and when I went to it, I searched for Mars. And guess what I found? I found several properties on Mars listed for sale, and it was funny as heck to see it, because it was actually a very real listing for a property on Mars. It doesn't really exist, but man, it was like $80,000 a month. You know?
Oh yeah, what was it, like 2 bedrooms, 2 bathrooms?
Yes, exactly.
You know, like.
Yeah.
Talk to your landlord, no smokers, pets allowed, you know, like,
yeah.
It was detailed. And don't ever tell a Gishwisher something can't be done.
No,
because we prove anything can be done every year.
I get
and
it
it gets out, and some of them are like, bake bread, or like bake muffins and bring them to a retirement home. One year it was dress up like characters from Alice in Wonderland and have a tea party with a child in hospital. You know, some of these are like really, really good. Some of these are ridiculous. But you know what? It's worldwide. You get out in the community. You get involved. You have a laugh. It's all for charity. I mean, it's win-win-win-win. So I may do a stream later on this week. I don't know if I have time. And yeah, looking for people from all around the world. If anyone out there is in Russia, I'm looking for Japan, China, Australia. Arnie, if you're around, I need to talk to you.
That's
Heidi,
funny.
oh, she's gone, but I need to talk to her. Yeah, so
cool.
But back to space. it did, a lot of them happen to be space inspired. When we had to send a message to Voyager 1, we had to tweet a message to Voyager 1, and so if you have ideas on a really, really good tweet that I could send to Voyager 1, please let me know in chat. I'm looking for something really funny. Like, I like
home,
the
you forgot the car
turn around,
keys.
you forgot your keys. That's kind of good, but something really, really good. Something that's going to get attention and laughs.
Yep. I'm just taking a 1 second
Sorry.
exposure here. That's okay.
That was way more than 2 minutes.
No, that's okay. I mean, they gave me a chance to check the weather, and I'm noticing that we've got a very large cloud bank coming in, and I'm hoping this doesn't terminate us, but I'm going to keep going as long as I can and see what happens. A
lot of people are picking up Mars, Pennsylvania. That's hilarious.
Yeah, I know. That's right. That's where it was.
Yeah.
All right, I'm heading to another location now, and it's right nearby, and it's another double star, and there it is, coming into position, coming into view. This is called Rasalgethi, and it is actually a very famous star because it's the brightest star in the constellation Hercules. And Rasalgethi is actually a 360 light year distant double star, but the components are separated by 500 astronomical units, 516 astronomical units. So it's pretty close. So I'm going to come in and try to show the two components as I zoom in here. Pop this up. Pop over to it.
I think Tana has a guess, or Tina, sorry. I think Tina has a guess on that last binary star.
Okay.
Is it the vampire zombie kind of thing?
Oh,
Is one a vampire star?
Very good guess, but unfortunately no. But that's a very good guess.
That is a good guess.
Yeah, but that's unfortunately not what's going on there. But I gotta reduce my ASA here for just a minute, my ISO rather, to show a little bit of what's going on here.
And hello to Ronald. Hello to our friend Jude.
Oh, good.
With FX Models, proud sponsor of SkyTour LiveStream.
That's right. Jude is with the FX Models Planetary Replica Division in Arvada, Colorado. Great to see you, honey. I'm glad you could join us. Ta-da! Okay, and now, let's see what I got here. Jude is also making some very cool materials for the Devil's Tower UFO Rendezvous. Yeah, I'm getting, you can just see those stars. You can see the two. Unfortunately, the sky is, it's making it a little difficult, but can you see them? Can you see the two components? Not while I'm shaking the computer, you can't. Yeah, they're there. And you can see that they're, you're looking at two stars at 370 light years away. They're separated by 516 astronomical units. I mean, that is incredible. So, that's really, really cool. And I'm looking in the sky now to see if we're going to be dodging clouds for long, and we might be. So what's interesting here is these two components of these stars are really cool. The telescope easily separates them into two stars that you can see. And the interesting thing is that the bright one, the reddish one, is actually an M5. Right at the end of the class scale, M5. But it's a 1B-2, as in one, IB, II. And it's a massive supergiant. Okay, so again, the music's appropriate. Okay, 360 light years away, but it's a massive supergiant we're looking at. And then the star is basically 400 times I think let me see here. 400 times the radius of the sun. So it's big, massive. Now the other star that is in that system, that little faint one next to it, it's an F2-5. It's a normal dwarf. That is a normal hydrogen to helium fusing dwarf, just like the sun. The sun's a G2-5, so it's pretty cool. I really like this, and I think that as a supergiant, the star is actually the F star. The M5 is actually really, really cool. Really cool, and I wish we could see it a little bit better than that, but we're fighting a few clouds in the sky right now. But
don't say the C word. While you're on the subject of the sun, yeah. Rockstar wants to know: does our sun have a binary star?
Our sun is kind of rare, but it does not. It doesn't have a binary star associated with it, and there are stars that do. Okay, many stars do. In fact, it's sort of rare not to have a binary system nearby, but that's okay. We're happy that we're not a binary system, because maybe we wouldn't have survived. Maybe we wouldn't have come about at all. The stellar winds from such stars might actually have hurt us. They could have made it very difficult for us to survive. And luckily, that didn't happen here, so we were lucky. you know? So
I
no.
don't know. I'm debating on whether I should ask it or not. Okay, the brighter one is the K5, and it's
No, it's an M5.
M5. Sorry.
That's
Oh
why
yes,
that's why
M5.
it's a little bit red.
Okay, and it's 300 times bigger than our sun.
400.
400
times the radius of our sun. So it's quite big.
Does that have anything to do with why I'm seeing the kind of rays coming off of it?
No. That's actually just the turbulence of the air right there.
Oh.
And it could have to do with a little bit of my telescope requiring a little bit of maintenance. I came out here to collimate it the other day. Collimation is a process that really takes some effort to get right, and it's hard to do it alone, but it's good when you have a video feed. So I had a video feed and I was just doing it, but it's cool, and I'm thinking that we're actually doing pretty good, you know. Oh my god, yeah, these I don't like these clouds. I'm sorry. I'll do what I can. I can see there's one more thing I can go to, and I'm going to do it right now. I'm going to take us to Antares, because that was requested. And I'd like to show Antares. Zing! We just left it. Boo! You saw it disappear.
I will.
Oh, come on. You know you don't see everything right at the same time.
I was just about to say, I think the people in chat get it, but for anyone that's just coming in that might not have heard this before, I can hear what Mark's saying in real time to me. You guys hear it 30 seconds later, so what he's saying will sync up with the picture. But I'm seeing the picture live on YouTube with you guys, so I can type my reaction at the same time as the people in chat, but when I say it to Mark, you will hear it 30 seconds after the image. So it's going to sound like either I'm lagging or I don't know, because he's not sharing his screen.
Are you sure about
on
that?
Skype. Yeah.
Are you sure about that? Because I thought that they would just hear both of us at the same time when we're having
Well,
a
they will, but
conversation.
okay, say you take a picture and you zoom in, you're going to say, look at that, isn't that beautiful?
Right. You'll see
and
it.
when they hear it, they'll see the picture and they'll say, yeah, that is beautiful.
And you won't
And when
see
they
it.
comment it's beautiful, I'll see it, but when I comment, it's going to take 30 seconds for them to hear that.
That's correct. Okay.
Yeah. And when I say, no, I can't see it yet, yeah, they're hearing that live, even though they'll hear me say it when it's on the screen.
Okay.
They'll hear me saying, I can't see it yet.
You know, you're confusing me now.
Chat gets it.
I don't. Look, come on. I'm an astronomer, not a rocket scientist. I don't get this stuff.
It's YouTube.
I'm kidding.
And Skype.
Okay, so this is Antares. Now, what I like about Antares is that this star is massive. It is a very, very large star, and it's a red supergiant, and it's an M2, and it's a 1 star. Roman numeral 1. So it's an M2 1. Very low surface temperature, about 3,500 degrees Kelvin, and it is it's a first magnitude, meaning it's a fairly bright star. You know, the 0 is very bright. Okay, like Vega 0.05 or something like that, and then Antares is a magnitude 1 star, and it's actually quite bright. And then, you know, as the numbers get larger, they actually get dimmer. So a magnitude 15 star is very faint. We can see a 15 with this telescope actually easily, but we can't see a magnitude 20 star, for instance. That wouldn't be possible for us. So now looking at this star, we can say, as I move it up, nope, I accidentally focused. I didn't want to do that.
Do you know what magnitude the cat's eye is?
Cat's eye? Yeah, that was well, not offhand, but yeah, I can get that. It's not visible right now, though.
No, I was wondering if you knew offhand. That's okay.
Yeah. Now, see, the thing is, this star, okay, this little tiny star we're seeing here is 65,000 times the brightness of our sun. So, if it was really where the sun was, it would, of course, sterilize us, even at its brightness. Of course, the reason for that is because we would be inside the star at that time. It is such a large star that the star would probably go out at least to the orbit of Mars, I believe, maybe a little before. One of the bigger stars in the universe will actually go out to the orbit of Jupiter almost. So that is an even bigger star, and that's cool. Now I'm going to just take a quick 2500. Is it 250? No, what am I doing here? Let me just check my settings. Okay, I was on 250. I want to go higher. I'm going to do a ISO 2500 shot at 1.3 seconds of Antares, just to look at the area around it. We'll see a few stars. Not yet. I gotta do a little more. Okay, let's do that. Let's go 5 seconds at 2500. 2500 is pretty low, actually, so, let's see what we can do. Yeah, that's showing it. I want to go just a little higher on the ISO. I'm going to go up 2 stops to ISO 4000 at 5 seconds, because I want to show you something. Yeah, that's, let me do it this way. Bring it in. Okay, that shot right there, alright, versus this shot right here. This shot bleached it out because of the length of the exposure. This shot shows it well. This image, if you notice, look at the background color. The background color of the sky is blue. What is that blue? That blue is what I told you about before. It's the result of the atmospheric scattering by the reflected moonlight, and it's actually creating a scattering effect, basically a blue sky effect in the sky around Antares. So that's how this works. Okay, it happens no matter where you look in the sky with a moonlit night. If you take a picture, you're going to get a blue background, or if you bleach it out like I did, you'd see that it looks like this one here, not that one, that one. Okay, and when you look at the star, okay, there's the star itself. This is a little bit higher ISO. You can see that Antares is just a brilliant orange star, and it's just beautiful. Now it is an M star, but it's a supergiant. It's got a very, very low surface temperature. So again, we can do our trick and defocus it a little bit, and I'm actually doing that manually rather than using my telescope controller. I was just going to see if it worked, but it didn't really work as well. Let me pop us in here. There you go. Look at that, huh? So that's a brilliant orange star. It's just brilliantly orange. Beautiful. So that's Antares, supergiant. And it's, again, big enough that it will go out almost to the orbit of Mars. Which means, of course, we'd be inside the star if we were there. Alright, I'm looking at the sky here, so give me a moment as I rotate the dome. I'm going to take us off Antares. You won't see it.
Wait, can we see the secondary here?
No, we can't.
Oh.
I'm just looking in the sky here. I've got the dome off of it, so you can't really see it too well.
Would we ever be able to, like, on a different night with your telescope, or?
Well, I mean, I could do photographically. We could.
Oh, okay.
Perhaps, and I would have to investigate the the properties of the secondary, the second star, to see if that's even possible with this telescope. There's something called the resolving power of a telescope, and there is also a limit to how close a separation you can see with some stars, or of some stars, because of the nature of the telescope. So it's not that easy, but I will check it out. I'm a little disjointed just because I'm looking at all the clouds that just suddenly appeared, only because we wanted to have some fun. So I'm gonna take us to one more thing before we lose it for good. All right, and we're gonna go there now. You just saw it zing right through the field, and it's gonna at the top.
I heard it.
Yeah, it's gonna come back here in a second. Okay, this, of course, is Saturn. And what I want to do is I want to zoom in just to make sure my focus is right.
Oh, I didn't know we were doing planets, too.
Oh, why not?
Can you see Neptune?
Can we see Neptune? Well, yeah, in fact,
I know we got Pluto small on P&K one night.
We looked at Uranus one night here, didn't we? Remember? We did. Okay, so now I have to just focus a little bit. Okay, now I gotta just come out of this for a minute and give myself a suitable target. And now I can focus better. Okay, and there's Saturn. Now we can actually see any moons of Saturn by just increasing the exposure time a little bit, and I will do that, and then we should be able to see.
And did you say you collimated your scope?
I did make some adjustments to the scope.
Okay. Ian thinks it looks better in defocus.
Let me do 2 seconds at 4,000. Let's see what we can see here. Okay, there we go. I see one, and that's actually, we're actually looking at Titan. Okay, see, I wanted to show you Titan. There it is. Okay, so now if you look to the right of Titan, to the right of Saturn, okay, that moon right there to the right of Saturn, that little tiny thing is Titan. Isn't that cool? I like Titan. Titan is an interesting moon because it's the size of a planet itself, and the Titan is actually a kind of a snapshot of what the primordial Earth would look like if it wasn't, so frozen. The primordial Earth, basically looked like Titan at one point, and so that's an interesting parallel. And so that's why we went to Titan, to see what there was. There was ethane and methane lakes, liquid lakes of ethane on Titan, and this kind of environment is so hostile to us that we immediately think, well, no life could exist there, and we have to say, well, no life like us, for sure. But guess what? Underground, underneath, then it's possible that there is, there could be some life underneath, and that's something that we don't really know. I've got clouds in the area here, so actually it's a fairly fat cloud, so I'm not going to be able to see through that. That's for sure.
David wants to know how you could switch from a focus or shots to another so quickly. Does your scope have something like presets? Does he mean when you're flipping?
Oh, you
camera?
mean? You mean when I
camera pictures?
Oh no! I actually, my telescope actually has well, actually, the camera itself, all right, has a ability to just do these zoom features, so I can actually jump in to get tighter and take a look at different things like that. I can zoom in. It's a preset thing though. I can't zoom in more than a certain amount. I have to rely as anyone else would on a Barlow lens, say a lens to actually make it do that. I already have dew on the telescope too, so
Good.
that's another issue.
So you said like Titan had so many parallels to what Earth might have been.
Yes.
Way back.
Yep.
Do you think there are other maybe moons or exoplanets out there closer, or do we just know about Titan because that's the only one we've really explored in depth? Like, is there something closer we know about, or is it just because Titan is kind of where? Like, what about like Enceladus or something?
Well, okay.
Or Ganymede?
Well, first of all, the one thing that Titan has that Enceladus doesn't is an atmosphere. In fact, Titan has a relatively rich nitrogen atmosphere. And for those of you who know about our atmosphere, you know that our atmosphere is made mostly of nitrogen. Oxygen is sort of a secondary pollutant in our atmosphere. And yeah, I said pollutant. I might have mentioned this last time, but planets don't like to have oxygen in their atmospheres, okay? Because if you look at what oxygen does, oxygen catalyzes, it oxidizes. Okay, that's oxidation is something that
Turns things to rust.
Yeah, I mean that's right. On Mars, for instance, okay, what did it do? On Mars, it actually it created iron oxide. When Fe, iron, combined with oxygen, it became FeO2, and that compound is the oxidized form of iron, which is rust that we know. And when you look at Mars' surface, you see that in fact it had a lot of oxygen and water in the atmosphere. The water vapor was probably hit by the ultraviolet rays from the sun and disassociated, meaning it was broken up into the hydrogen and oxygen components. And now that free oxygen combined on the ground with the iron in the crust, in the sediment, and became rust. And so Mars is rusty, and that's why it's red. And that's kind of a interesting revelation if you've never heard that before, and that's a kind of an interesting thing. So that said, it's actually interesting to talk about, because not many people actually realize that Mars is rusted. And what that tells us is that Mars had an awful lot of water at one point, and more importantly, an awful lot of oxygen. And that oxygen is it was probably bound up with water, H2O, okay, and it went away. And that there's a lot of reasons why it could have gone away. The planetary world, we look at a lot of different things, and one of the things is that the water on Mars probably was affected by the heavy-duty ultraviolet rays from the sun. And tell me if this noise is a problem, because I'm using the hairdryer to dry the dew off the telescope. I don't know if you can hear that.
Is it on now?
It is.
I can barely hear it.
How about now?
I can hear it a little more, but it's not overpowering.
Oh, good. That's very good. Yeah. So, so the oxygen ended up getting taken out of the atmosphere basically by ultraviolet radiation from the sun that got through Mars' thin atmosphere. The other thing was Mars didn't have a magnetic field for very long, and that the magnetic field, of course, is due to having a molten core or molten outer core on a planet. Like with us, we have a molten outer core and a solid inner core, and the molten outer core rubs up against the inner core, creates electrical currents, and those electrical currents generate magnetic fields. Those magnetic fields end up being our protector. They save us, and that's something that we don't have that we don't have on Mars. So that said, for a lot of reasons, Mars doesn't make the cut. And that's too bad, because it means that the atmosphere that was on Mars has partially been removed and partially been disabled by the sun itself. And then there are other reasons, of course. The issues with the magnetic field not being there is a big problem. So you know, that's just unfortunate for us. Now, terraforming Mars won't likely be in the cards because I know that it's a big thing and I know it's science fiction, but the atmosphere of Mars is only 0.08 that of Earth, so you might as well be in a vacuum. You know, it's really not a very deep, massive atmosphere. So that said, I don't think that we're gonna be able to terraform it very easily. We might, maybe we could, but you know, it's gonna take an awful lot of effort, technology, and we don't have that technology. We just not yet, anyway. Let's see. Looking up here.
There's some chat going on here. Tina said she thought she read an article where they're trying to reclassify the moons and planets again. Did you hear anything about that?
I have not. I haven't looked into that. I haven't looked at that at all. I've been
No,
actually,
you didn't hear anything about that.
No,
No,
I
I
didn't.
hadn't either, so I was just wondering.
Yeah, no, I did not look at that. I didn't see anything about that. But that's okay. I mean, it's just, you know, is what it is. Let's see now. If you think about it, we did that already, didn't we? You know, with Pluto.
Well, that's where discussion was going. It was like, can we bring Pluto back? And
Yeah, good luck with that.
I see. I mean, I was totally on board with, yeah, Pluto should never have been demoted, but I kind of like the theory that we may have stolen it from somewhere else and added it to our solar system, and it has never yet orbited the sun, right? It's kind of a...
Well, no, Pluto has definitely gone around the sun, you know, quite a bit. I mean, it's not like it's, you know, that recent. Not at all. Okay. But it's definitely a strong possibility that maybe it's what's called a capture. It was captured, and if it was captured, then we will see a you know, a different orbit, which we do. We would see perhaps a different inclination to the orbit, which we do. You know, Pluto's not a perfectly circular orbit. It has a little bit of an elliptical orbit to it, and it's on an angle to the solar system. So it might be a captured object, which is interesting. And I think that's all part and parcel to understanding the planets in our solar system. So, do you know what this is, by the way?
Oh, I was looking for.
Okay, this star here, this double star is 162 light years away.
It
vanished in a cloud, but it'll be back in a minute.
I didn't think they were up and down like that, and it probably isn't. And I don't even know if it's a double star, because it's kind of it would be two heads of a constellation. Am I way off?
Yes.
Okay, what are we looking at?
It's a double star. This is Epsilon Lyra. Okay,
I didn't think they were up and down either.
Well, remember, it depends on the angle of the telescope and the angle on the horizon. You know, so the angle of the telescope is going to determine sort of the angle. That's called the position angle, the angle that we're looking at. And of course, we're not looking at it at all right now because of the clouds. But like I said, I'm looking and I'm seeing that this cloud mess that just is currently in our way is passing, and it'll be coming back shortly, I promise. Watch, I'll be a liar. Woof, and it just like gets totally covered, or just stays in that one place. That's even better. All right, let's flip the dome around and take a look. I can actually do it this way because now we can actually see in the direction the clouds are coming from. Oh yeah, well, okay. You know, I gotta say, I mean, the best intentions. I wanted you to have a really nice night here with our double stars. but sadly, we don't get to control the weather. Not yet. I mean, we may eventually.
Yeah, some would argue that point.
You know, and I guess the point is that we're not able to control it now. So who knows? Will we ever be able to control it? I don't know. Anyway, so
well, if we're working on ways to terraform Mars, then yes.
Yeah, maybe. But
you don't, I guess, have your backup app set up so we can throw planets at each other.
Well, actually, I would have to close the stream and then restart it.
Oh, okay.
Which is not a big deal, but it seems like the clouds are just like hanging, and making it crazy. So I'll just tell you some more about Epsilon Lyra, just a little bit more, and then see what we get, and see if we get something that improves.
I see something interesting about what we're looking at.
What's that?
Epsilon is the other tip of the fish's tail in Lyra, Vega being the first.
Oh, yeah. Except that...
Yeah, I like little things like that. That will help me remember. Okay, I'm looking at a fish tail, so this must be Epsilon Lyra.
Yeah, except Lyra's a harp. Oh. Lyra the lyre, It's a lyre as opposed to a... it's not a fish. Maybe in a different mythology it's a... I'm not sure. I don't know in other mythologies. But that's something you can...
Is it anywhere near Pisces?
No. I'm sorry.
I don't know, that's the first thing I think of when I think of fish in space.
Of course. You do. Yeah.
Well, and that could get confusing too, because if you're looking at one group of stars and you're seeing like 10 different pictures in it, that could get just as confusing as all the different names, like all the different, like,
that's
one's
correct.
an M and one's like a, what was it?
Yeah.
NSC or something, or a...
Yeah.
Yeah.
Yeah, that's true. That is true. Alright, so...
I like stories better than numbers, so keep them coming, guys.
I know you do. I mean, you're... So, do we have any takers on why those binary stars we were looking at were different ages?
I think they probably dropped that. They were thinking one mass was stealing another. I know Daryl said something more after that, but that's so far back up in chat.
That's okay. No worries. I'm just moving right now. Just gonna...
But yeah, I think everyone really liked the vampire idea, and because I don't know, that doesn't make sense. It like
okay, well,
okay, well, one's aging faster than the other. Then one circling the other faster and therefore aging faster or something.
No, it's not a it's not something that's a like a time dilation thing. But that's a good thought. But no, I'm sorry.
That's an interesting question. That's a I don't know. I think you may have officially stumped chat for the first time, because they usually come up with the right answer. Well,
yeah. Well, I was very careful not to give them the name of the star so they could look it up and cheat. That's okay. All right, I'll tell you. The answer actually is that the stars we saw right next to each other, only a few thousand astronomical units apart, were actually not a true gravitationally bound system, meaning they don't orbit each other. The stars are actually just a line of sight double, meaning that they're only a double star as far as our view from the Earth. When you go out in space and move in, like, say, several light years in another direction, then you'll actually see that those stars are actually separated by more than more than just the apparent distance they appear from the Earth. So, not a trick question per se, but it's actually a study in 3D spatial analysis. So there.
Well, let's take a poll in chat. Was that a trick question?
Come
I
on,
don't
I
know.
don't think so.
Well, a lot of people would disagree so far.
Oh well, you know. It
Well,
really,
because no, if you're focusing on double stars and it's not a okay, what was it called? If it wasn't a double star, what 2 stars were we looking at?
well, we're actually looking at a star that was actually that Kappa Hercules, but it was actually a star that was together they make one apparent star, and that's what we saw. There's actually a lot of these fortuitous doubles in the sky. We'll see them a lot, and it's not like that we know the difference right away, because ancient peoples didn't know the difference. They had no idea. They thought these stars were next to each other when they were actually looking at them, so they didn't know. And similarly, we didn't know for a long time. I mean, even Polaris is a double star. The North Star, Polaris. So that's pretty cool,
Just to let you know, we have Mr. Schmidt's science class joining us. Is there any chance we could peek at Saturn one last time before we go, or has it clouded over?
No, let's see what we got. I don't think it's... Oh yeah, it's... Well, wait a minute. That's kind of interesting. Let's see if we can look at it. Dave, your science class is here, the whole class?
Well, because I saw something earlier. He said my science class will be here at 9:40. I hope you guys are still around. So I was thinking,
oh well, then you know what?
That's an awful late time, unless he means in the morning. And obviously, we're not going to be doing that 12-hour stream. But so yes, good evening to Mr. Schmidt's class.
Yeah. Well, in that case, let me see what I got here. If I got something else I can do, I might. Let me try this. I would like to, give them something if they're really here. Dave, tell me if you guys are here, because I would like to show you something here that.
They are. He said, Mark, my class just asked if they could see Saturn again for a moment.
Yeah, I will. I'll show them Saturn in a moment.
Mhm.
Let's see.
You have a treat, class.
Yeah, I want to try and see if we can. I want to show them one of the. Oh, this might be.
It's important for anyone in chat. Ask, and we will do our best to make it happen. If you have a question, if you have a comment, if there's something you want to see, put it in chat. I am watching. I will get it to Mark.
Awesome.
And if it's not cloudy, if it's like the right hemisphere, if it's up high enough, we will do our best.
Absolutely.
Or if it's something that comes up in the winter, subscribe and hit the bell, and we will definitely make notes to bring you everything we can.
And we will. Okay, now what I'm going to do is, I want to show, since his class is here, I wanted to give them something to look at that's really kind of interesting. Now, we got a little bit crappy cloud that's kind of in the way here, but I want to see if we can do it. I'm going to take an ISO 8000 picture at 2 seconds. Not quite, but let's do this again, guys. Hold on. Almost there. Okay. How about now? Okay. This'll work. Alright, guys. So, to Mr. Schmidt's class, this here is a very interesting object that's actually very far away. It's the globular cluster called M13, or the Great Hercules Cluster. Now, the distance of this cluster is an astounding 23,000 light years, considering that the nearest star to us is 4 light years away, and it would take us 19,000 years to get there at the fastest speed we can. This is 23,000 light years away, and it actually orbits the galaxy along with dozens of others just like it, globular clusters. These globular clusters are among the oldest objects in our galaxy. These stars that are in this cluster are actually the stars that actually have the least amount of other elements from our periodic table in them. Now, what does that mean? It means that the stars create the elements in our periodic table. And when we look at these stars, these are called population 2 stars. The ones that are more recent are things called population 1 and so forth. And the population 2 stars, old as they are stars that actually won't have more than, say, hydrogen and helium and maybe some trace elements in them. The rest of the stars in this gigantic cluster of what actually could be, 100,000 stars plus, okay? This could actually have, could be a cluster that doesn't have a single planet around a single star. And the reason is because planets are made of advanced elements that are made in stars and then recycled made into new things as these stars blow up and die. But the stars in this globular cluster are very old and don't have a lot of what we call metals, that is anything other than hydrogen and helium. So if that's the case, there's probably a dearth or a lack of planets around all these stars in here. And these globular clusters, as I said, they can have, several 100,000 stars. All right. Now, they're beautiful, and there's also some images that the Hubble Space Telescope took of this cluster, which are just gorgeous. And I'm just going to take another one just to give you an idea. I think it's relatively clear up there, and I'm going to go and take a 3.2 second photo. 3.2 seconds at ISO 8000. 8000 is a sensitivity number, okay? And the sensitivity is determined by the circuit in the camera that tells it how much light to take in, per millisecond. And the camera can process large amounts of a lot of light, okay? And as you can see, this is the center of that globular cluster. One thing to notice is that the stars are all a little bit different colors, aren't they? There's some that are a little more yellowy looking, some that are more blue, and they all kind of formed at the same time. But these stars are actually, again, very, very old. So there are variations as well. And now the reason I've been showing you this and not Saturn is because Saturn is behind a cloud right now. So I wanted to show you something that actually had, had a half a chance of being seen. And to that end, I'm going to show you one more thing while waiting for Saturn to come out of a cloud. I'm going to show you another object that is really, by and large, it's really one of the most beautiful objects in the sky. And I think you'll enjoy it. And again, I apologize for the noise. We've got construction going on.
David's class, they're in 8th grade. So basically like 12, 13.
Okay.
YouTube didn't even exist when I was 13. I mean, could you imagine, like, if you needed extra help in science class? That's what I was saying earlier. If I had this when I was younger, and I could just watch any kind of level I wanted for free anytime I wanted.
Yep.
I mean, and now having the opportunity to do it live.
Oh yeah.
I mean, this is just genius, especially for kids that age. You can see it live, and it really makes a difference. It does for me.
Yeah, well, this is live deep sky astronomy, which is something that I never had access to. So when it became accessible, I just said, you know what? I'm gonna do it. I'm gonna do this, and I'm gonna make sure that I do it as good as anyone can possibly do it, because I would love to be able to show people the night sky. So. And
it is different from just uploading it, because you could very easily, edit this and make it all, produced and everything, but to have access to it live, to ask your questions live, to
and speaking of that,
zoom in on exactly what you want to see. Well,
And speaking of that, on the screen you can actually see clouds going in front of this deep sky object, and they will move away shortly, and I'm doing a 4K video. 4K is basically twice HD definition, and this is video that I'm shooting right now. And I can actually shoot this. I'm shooting this at 32,000 ISO. And when you have a regular camera, your regular camera can go, you know, camera has speeds for the sensitivity settings. There's like, you know, 100, 200, 400, 800, that kind of thing. And most cameras go to say 3200. My camera goes to 409,000. Okay, so right now I'm at 32,000, and I can go up. I'm just gonna kick it up. This is 40,000. This is 51,200. This is 64,000, and you can see now that we have a cloud that is just being a real stickler. It's looking down at me going, ha ha ha, you want to see this? Well, no way, pal. But not to worry, because clouds all pass, and this will go away too. And what I want to show you is the little thing that you might have seen a little briefly in there for a split second, and it's going to come back in just a moment. Okay, so you can actually see the clouds passing, the stars are staying still, and now you can see that little tiny donut looking thing in there, and that is something called a planetary nebula, and it has nothing to do with planets. This has to do with a dying star. We're actually seeing the remains of a dead star. This is called the Ring Nebula, or M57, and I'm going to come out of 4K mode and go into live photo mode, and I'll take a photo for you just so you can see it. This is 3.2 seconds at 32,000 sensitivity, or ISO. Okay, and there it is. Now if we zoom in on it, okay, we come in, you can actually see, you know, the sky's a little turbulent tonight, but you can kind of see this, but I'll do a little better in a second. Okay, it's cleared. So now what I'm going to do is take another picture, and I'll do it at, say, 6400 ISO, and we'll go to 5 seconds and see what we get. So we're taking the picture right now. That's why the screen is black. Okay, there we go. Let's go check it out, shall we? So there's stars all around, and you got this little smoke ring. And what we're looking at is the remains of a dead star. Right in the center of that ring, you can actually see a little tiny dot. That little tiny dot is all that's left of the star. But it's hot, and it's still radiating energy because it's a star core. And it's actually causing the nebula to light up like you see it. It's not reflected light. It's causing an atomic interaction with the elements in that ring of gas, which was former star material that was making up the star. And what it's doing is it's actually causing them to emit light. All right, so you see kind of blue on the inside, and then it's sort of reddish around the outside. All right, that's the Ring Nebula, and as an object, you know, we have to say, well, what is that object actually composed of? Well, it's composed of the gases that were once in the atmosphere of the star, and as the star evolved, it became a red giant, and when it started to shrink down, it left its outer atmosphere out there because the atmosphere was starting to move away from the star as the star puffed up, and the outer atmosphere kept going. So it sort of just like puffed off the star, and that puffing off of the atmosphere caused this nebula that you see. Now, why is it a ring shape? This is something I took everybody in chat through before, but I'm going to share it with you because I think it's really cool. If you imagine holding a grapefruit in your hands, put your right hand on the right side of the grapefruit and your left hand on the left side of the grapefruit. Think of that grapefruit as a spherical shape, kind of like this Ring Nebula. This Ring Nebula is not flat, it's a sphere. But how can that be, you might say? Well, think of it this way. If you have your fingers apart and you're grabbing that grapefruit in front of you, if you grab it from the front and the back, you can actually see through your fingers. You can see through your fingers in between them. All right? And if you hold it from the sides, you can't see through your fingers. Now let's look at the nebula. The nebula where it's thick on the outside like that is where you can't see through your fingers. And the nebula where you can see through your fingers is on the front, in the hole, in the front in the hole, and on the back side. So this kind of explains how wherever you are in the sky, this may very well look like a ring, because it's going to have that thinness in the front and the back because it's less material. On the edges, there's more fingers in the way, so to speak, when you turn your hand sideways. Now, if you look also to the just to the upper left of the nebula and to the lower right of the nebula, you see that there's little kind of fuzzy extensions of red there. Well, that's something that was basically recently discovered in the last several, well, I'd say maybe the last 10 or 15 years. And that's something that indicates that the nebula has something called bipolarity, or it's a bipolar nebula. What does that mean? It's a big word, but who cares? It just means that the nebula is actually squirting out when the star was expelling this material, it's squirted out either on its equator or at its north and south pole. And so we're actually seeing more material near its poles, say, than its equator. And so it looks like it has a little bit of a line through the center on a weird angle, like we see from a little bit above left to the lower right. And that's what's called a bipolar planetary nebula. Remember that. When you go home tonight, say to your parents, I saw a bipolar planetary nebula tonight. And that's right. And when they say, what is it? You say, well, I'll just have to say that for another time, because I'm sure that's going to make your brain explode if I have to explain it to you. And then just walk away. I think you'll have fun. So, that said, after all this, Saturn has cleared. So you saw.
Why is it blue?
Well, the blue has to do with whatever the particular elements that the star is exciting in its former atmosphere, and they're actually emitting this light. And I have a spectral system that I finally got up and running. And when I use the spectral system on this star, what's that going to do? That's going to show us the breakdown of the colors that are in this. But in those colors, there's going to be potentially some dark bands. Those dark bands will tell us what the nebula is made of. And that's something that's going to be very interesting to do. All right, so now, by request, shall we see Saturn?
Yeah, well, that was actually a question from the classroom. David said they were getting a lot of wows when this came up, and they wanted to know why it was so blue. And Daryl's also saying maybe we could touch on what elements do the colors represent.
Oh, well, you know what? The colors, okay, in the star's atmosphere, when a star is expelling its outer atmosphere, you actually have a number of elements, because remember, inside a star, that's where the elements are made for the periodic table of the elements. Now, if you're in 8th grade, you may know that we have a periodic table of the elements, maybe. You may not be fully versed in it until you get to high school, but that's okay. A periodic table of the elements is basically a listing of all of the elements we have found, like potassium and lithium and beryllium and all those elements that we know, hydrogen, helium. So, and Amanda will not tell you, and I won't tell you, that
Will Amanda know?
Well, that I actually memorized the periodic table to a song, and I will not sing that song. But I will tell you that if you look up the periodic table of the elements song online, it's very funny. And it's a song that starts as there's hydrogen and helium and lithium, beryllium, It's the can, which is called the can song. Anyway,
so much for you not singing it.
Well, I didn't go through it. I didn't do the whole thing.
Enough to give us an earworm.
An earworm.
Tune that gets stuck in your head.
Sound good. Yeah. Anyway.
The can.
Yeah. So anyway, considering that this is a very interesting nebula, the colors are due to, most likely, there's hydrogen, there's helium, okay, and there's other elements in there too. And it's not just helium, straight helium, okay? There's something called an isotope of helium as well. Isotopes of oxygen, okay, that are formed in the star's atmosphere. Yes, stars make oxygen as well, but not because they need to breathe. It's just because that's one of the elements in the periodic table. So that said, we would see a really neat, we'd see a really neat spectral signature, that is information that would tell us exactly what's in that nebula with the spectral system. And once I have it up and running fully and put it back on, then I think that we'll have a blast looking at the spectra, don't you think? I do. I think it's going to be great.
I loved it. It was gorgeous.
Now I'm going to move us now to Saturn, as promised. I had to delay Saturn, guys, just because I was trying not to, show you clouds instead. So that's all. All right, so we're going now to Saturn. Here we go. You're listening to the telescope motors steering us down to Saturn. And if I come out of this, you should be able to see Saturn coming in.
Yeah, I'm sure that David explained that you actually have a dome. You're out there physically outside with a telescope, moving it around and manually doing all this outside. It's not remote. It's not all computers. He's physically doing this for us. So thank you, Mark.
Well, that's okay, but I am actually using computers. I do have an i7 computer, which is actually controlling the observatory, but I am manually, not manually steering to objects. I have a database within the telescope, in fact, and I actually have a Wi-Fi connection that I made for the telescope, so that I can connect to the telescope with Wi-Fi, just like at your houses when you go to connect to the internet. And that Wi-Fi connection is a connection that allows me to control the telescope completely with my iPad. And that's exactly what I'm doing. I'm holding the iPad in my hand. I'm steering to different places, and I'm getting you information. I'm showing you things on the screen. Now, this thing we're seeing on the screen now, this is Saturn, but it's a little bit overexposed, and there's a reason for that. The reason is because I want you to see the little dot there in the middle. That little dot, okay? So this dot that you're seeing right there in the center of the screen, okay? That dot to the right of the overexposed Saturn, that is Titan. That's Saturn's moon, Titan. Now, Titan is big, and Titan is nearly the size of a planet, as I said. But Titan's a wonderful moon of Saturn because it resembles what the Earth may have looked like. Now, Titan's also in a deep freeze. And I'm thinking, what I'm trying to say is, before the Earth, became what we know, it had a different kind of an atmosphere. In fact, its atmosphere was 90 times denser than it is now. And it was made of many carbon dioxide, nitrogen, and other materials, methane, okay, and so forth, and traces of ammonia, water vapor. And Titan has a similar atmosphere. It's very heavily nitrogen. So, and we can actually see that Titan is actually a little bit orange here, and that's because it is. Titan is actually orange, has orange hazes in its atmosphere. Now, I'm actually going to turn down the ISO a little bit. I'm going to pop back for just a sec. I'm going to go down to, say, 250 and then zoom in again. Let's see what we get. Just trying to get rid of, yeah, there we go. See, now you can actually see a little better Titan on the right. But if you notice, you look just above Saturn, and what do you got? There's something else up there. What is that? Well, that's Tethys. That's one of Saturn's moons, Tethys. And to the left, you actually have a little bit of a moon. It's just a little bit to the left and a little bit down lower. That, believe it or not, is Dione. That's Titan's moon, Dione. Now, down near the bottom, we can't really see it too well tonight, but what's down near the bottom is Enceladus. Now, Enceladus is one of Saturn's moons. It's only 300 miles across, but it's covered with ice, so it's very bright. And when we look at Enceladus, we see the possibility that Enceladus has these very interesting features underneath the ice. How do we know that? Because right now, as we're looking at Saturn, there's also a space probe out there called Cassini that we've sent out there. And it's been circling Saturn for a number of years, and it's been zipping through the rings here and there, and it's been going by these other moons, and it's dropped the probe onto Titan, and that probe, called Huygens, landed on Titan and actually gave us imagery of the surface for the first time. It's really interesting imagery if you look it up. Now, Saturn is the thing I want to say about Saturn is that this particular planet is really massive, but it's also light as a feather. It's so light that if you could put it in water, it'd float. Okay, so it has a very low density, even that's what that means. All right, and Saturn is, if you want to think of it this way, the light from Saturn takes 78 minutes to get here from Saturn. So over an hour, right? And it's like an hour and 18 minutes for the light to get here from Saturn. And that's because even at light's speed of 186,000 miles per second, it still takes 78 minutes for the light to get here. That's how far away Saturn is from us. Now the Sun, on the other hand, the Sun itself is only 8 light minutes away. So the Sun is a lot closer than Saturn. And that's good for us because we're in what's called the habitable zone of our star, the zone that's not too hot, not too cold. They call it the Goldilocks zone, and that's where we are. Now, we talked about Titan. We talked about the other moons there in the field of view, Tethys and Dione. But now let's look at Saturn itself. Let me pop out a bit so I can drop down the exposure a little bit, drop down the settings.
And it's interesting you said that the light from Saturn takes 78 minutes to get here, or to be seen from Earth. Daryl actually said if you go out and like after dark and look south, you can actually see Saturn with the naked eye sitting above the tail in Scorpion.
Yes, it is.
So I mean, that's pretty fascinating.
Yeah, yep. I mean, I can
So
see Saturn.
far,
I can see Saturn through the dome in the sky, and I also see it here on the screen. Now, a modern observatory like this one, here's what we use. I have a camera, a special camera on the back of the telescope, and then there's an electrical cable, a cable that runs from the camera to a computer. The computer has a capture card which captures the imagery from the camera. Look at that cloud. We're dipping into a cloud. And it captures the imagery out of the camera, and then it will take it and put it through a broadcast software like we're looking at here. That's why you're seeing me and seeing this whole process, or not, based on the clouds. Believe it or not, that's the only location in the sky where there's clouds. Everywhere else is finally cleared up. We just have to wait it out a little bit. That's all. Now, I mean, if you want to blow out your eyes, we can always go to the moon. But the moon is actually, very, very bright, and the moon is also full, just after full. So it's not really that impressive. The moon is best seen. The moon is best seen when we have, a phase such that we can see shadows into the craters and things. But are there any questions out there from David's class or anybody else in chat? And I still have to tell you what... I told you about the double star. Sorry. Go ahead.
Yeah. No, David was asking if you can make the rings visible, which you had just done. So, because that's what they were... See, I wanted to actually know, maybe from chat or maybe from David's class, like... Again, I like science, but I don't remember... I don't know, like, I remember, at the time there were 9 planets in our solar system, and everything else was just kind of stars. I knew we had a moon, but it never occurred to me that other planets would have moons, and so many more than us. Mercury and Venus have no moons. We have one, but then, Jupiter has 69.
That's correct.
Mars has 2. How many does Saturn have? 5?
No. Saturn has 62 at least.
See, now, like, what age? I'm wondering, because some people in here, I mean, they have just loved astronomy since they were little. Like
Yeah.
you knew from age 9 that you were going to be doing this for your life. So,
Isn't that pitiful?
but like,
yeah, that's true.
what? That's lovely. I wish I was just knew what I was meant to do at such a young age and then went for it. And that's why I like this, because I liked science, but because I was so weak at math, it prevented me from going on. What age were people aware that other planets had moons? Because, like, I'm thinking, if I was in grade 8, knowing what little I knew, and you were talking about the moons of Saturn, I'd be like, wait a second, Saturn has moons? And you're talking about details of these moons, so it's like, was I just, like, that clueless? Like, was this something that would have been taught in elementary school? Because I don't remember that. And, like, all the elements of the periodic table being created in stars. I didn't know that.
No.
I didn't know that in elementary or high school. So is it just because I didn't take chemistry and physics and stuff? Or I don't know. Like,
no, because
this is such an amazing channel, especially for young people just learning about these concepts. I can't say enough good things. Sorry. Go on.
Well, I'm happy. Thank you. I mean, that's very kind. I do think that it's very important for anyone, young or old, to invest themselves in science, because if they don't invest themselves in science, then what else is there? I mean, to leave this planet, we're going to have to be heavily invested in science. Okay? Now, for instance, this object that I'm showing you here, which you haven't seen yet, but you're about to, okay? This object that you're going to see is another globular cluster. But this one is a special globular cluster. It's actually called M22, and it's in the constellation of Sagittarius. And M22 is special because it's really large. Okay, so when this photo comes back, you can actually see it. When I go into this, and the mode here, we actually see it. Now, as I show you this, okay, this cluster is actually a lot bigger than Messier 13. That is the Great Hercules cluster we looked at earlier. And this one, all right, this one is actually 10,000 light years out. So it's closer to us by more than half than the cluster in Hercules. All right, and this object actually is a it's another. They're called halo objects. They're outside our galaxy, circulating in our galaxy, circulating around, orbiting our galaxy. And what people don't realize is that we orbit the galaxy too. We're orbiting our galaxy every 230 million years. We go around once, and we've done it 19.5 times since we were formed. That's really cool. Now, the M22, okay, has a number of stars. It has like 70,000 stars in it. All right, so maybe a little less than the M13, but it is closer to us. And so we see this, like we see here. I actually want to see if I can. I'm going to tone down the ISO and increase the setting. I'm going to go to 13 seconds at 2500 ISO. I just want to get a richer core. That is, more stars in the center. It might be a little weight. Oh, darn it. I see a cloud. Okay, this is probably going to be clouded out. My mistake. I apologize. I just didn't see that little cloud. Yeah, you can see part of it in this view. But see, this is what we fight, guys. This is what we fight. We fight the clouds. It's like Game of Thrones. We're gonna fight the clouds. These are the Baratheon clouds. That's right. And then get rid of them, I'm Ned Stark.
It would have been better if it was
fighting
a
the
supernatural reference, but whatever.
Well, that's because you like Supernatural, and I was watching Game of Thrones. What can I say?
You got sucked in, did you?
I did. And I didn't even like it at first. I thought, what a lousy show. And then by the time I watched the 5th episode in season 1, I was saying, what a lousy show. Can't wait to see the next one. Then by the time I got to where I am now, which is the first episode in season 7, the current season, I was saying, wow, this isn't so bad. We got dragons and all kinds of things going on. know. Now, I want to just point out something here. When we look at this image here, okay, sometimes what happens is when the clouds come in, they do something for us. Clouds act as a natural filter. You can right away see which stars are brighter. You can also see some color, can't you? You can start to see that some of the clouds, some of the stars are actually a little more orangey looking. And I told you when we looked at M13 that some of the stars that were in there actually had a different color, but you really couldn't see it. In this cluster, which is more than half as close, as the other one, you can actually see some of the colors. You can see how the core stars are more blue. The stars on the outside, some are more orangey and red. Now, that's because the stars we're looking at may have been grabbed when this globular cluster was circulating through our galaxy. It goes down to, remember, our galaxy is a big pinwheel of stars, a big island universe of many stars, between 100 and 400 billion stars, in fact. So when we look at a globular cluster circulating through our galaxy as it goes plunging through the plane of our galaxy, that disk, well, it's got massive gravity, this globular cluster, and it's going to definitely pull off some stars as it keeps going. And these are a lot of stars here, these 70,000 stars in this cluster. Undoubtedly, some of those were in the galactic disk originally and are now in this cluster and got yanked out with it. So over time, its sky really changed because whereas we have a very faint Milky Way that we see when we look up in a dark sky site, we see this beautiful band of white star cloud. And maybe these stars originally had that view. But then after they got sucked out of the galaxy and dragged in by the gravity of this globular cluster, now they don't have a galactic view anymore that's like it was. Now they actually have a view from outside, more of an outside view of the galaxy. And then in the other direction they have this density of stars because they're looking from, say, the outside edge of this globular cluster into the core of the globular cluster, which is going to be a massive concentration as seen from within. That would be really cool to see. And I've seen some simulations of that. And it's possible we can do that with the simulator on our cloudy night streams. But for now, we'll just talk about it until we can actually do it for real. I'm just sticking my head out of the dome right now, just checking things out and see what we got. And it looks okay. Tonight we're going to be stopped by dew on the telescope. That's what's going to stop us. However, I have left the anti-dew machine plugged in, and I'm going to turn it on now.
Because we did actually have a question on a theory on gravity, but first, from David's class back to Saturn, did the probe that was dropped off on Saturn's moon get any good shots of Saturn itself? He's planning on showing shots from Cassini after the stream.
Oh, wonderful! Yes, Cassini itself is still delivering like you can't believe. It's delivering. It really is like. It's really like the hits keep on playing, okay? Cassini is showing us some miraculous views of Saturn, and you can find them all. You can actually go to the Cassini website through NASA and see the raw footage, in fact, the raw imagery from Cassini. And same as for Juno, which is the Jupiter mission. And you can actually see all the raw data there, too. And it's outrageously good. Okay, I'm going to change the battery in the camera because I didn't think it was going to.
But what about the probe that landed on the moon? Was it Titan?
On Titan? Well, that was the Huygens probe. Yeah.
Did that get any shots of Saturn?
No, it was actually more shots of Titan itself.
Oh.
But there is something really great about that Huygens probe. If you find the Huygens probe video, there's one that shows what Huygens saw as it came down through the atmosphere of Titan and landed. There's a whole descent movie showing what it looked like. It's beautiful. It's amazing. You're looking at an alien territory, alien planet. It's just like, wow. And if you were on that probe, you'd be saying, wow, this is my new home. I'm never leaving here. You know, I'm going to be landing, and I might last about, you know, a day or so, and then I'm not going to be around anymore. And that's what happened there. It's so cold and so dense.
The class has to take off. Thank you guys so much for dropping by. This is what I was hoping would happen. So tell your friends, share, subscribe, hit the bell. Do come back.
Yeah,
David, if you can find me on Facebook or something, you know, I would love to let you guys know whenever we're streaming. If the class had any questions or anything you wanted to see, whatever, you know, your kind of curriculum is going to be.
And David, you can also find me on Facebook too. You can friend me, and anyone in your class can if they'd like to learn. You know,
drop the link to the Facebook group.
Oh yeah,
SkyTour LiveStream with Mark D'Antonio on Facebook for any that have it.
Yeah, and my regular Facebook site, you know, my Facebook presence, you can go there as well. And just look me up, Mark D'Antonio, on Facebook. No apostrophe after the D. It's usually D apostrophe capital A, but I use DANTONIO for D'Antonio. So you're more than welcome to come along for the ride anytime you want. I always welcome the company on the SkyTour LiveStream, and thank you so much, David, for bringing your class to us. It was wonderful.
Yeah, and David, let them know about P&K if you want to see the moon and some planets, and let them know about Bill NY Skywatcher. He's actually following the early coverage of the Perseids meteor shower, so that's always awesome to watch.
And if you want to see us anywhere altogether, please feel free and enjoy the website we created called astroimaginglive.com, where all 3 of our streams are up there, and you can jump into any one that's active, join the stream like you see here on your screen now, or pop out and go back to the main site. It goes right back to the main site, takes you right back, and you can then join any other stream you want, or watch all 3 on the main screen together if they're all live, and you don't want to miss anything. Just put them all up on your screen and watch all 3 at the same time with astroimaginglive.com. And then you can participate in the chat on that main page as well, and ask questions. And of course, there's always mods, like Amanda's being a wonderful mod. She takes all the questions and helps me with them. She does a fantastic job, and I can't thank her enough, because she makes my life workable with this, because this otherwise would be very difficult for me to look at questions being proffered up in the chat. But anyway, that said,
yeah, I think I got some of the links in. The good thing with the Facebook link for the SkyTour LiveStream, a lot of the pictures he's taking live, he will actually put up there, so you can actually, you know, kind of play around with them yourself and download them. And
indeed,
yeah.
Indeed, yep. So does anyone in the chat have any requests or any commentary, anything they'd like to see? It's a moonlit night, so if you wanted to see like a faint object, that's not going to be that easy. But if there's a cluster you'd like to see, we can look at a cluster as well. That'd be pretty nice, because the moon can't really hurt clusters too bad.
They're talking about some mythology. Theus? No, Tethys? I'm pronouncing it wrong, I know.
Oh, Tethys?
Yeah. Was the daughter of Uranus.
Okay.
And Titan. Not a god, strictly speaking. They're just saying, Lorraine is here. Hi, Lorraine. Said that she remembered seeing a mosaic found in Turkey.
Okay.
Suggesting that she was a Greek goddess.
Mm.
I'm just reading the chat. That's what I love about chat. Like, everyone brings different aspects, and it just broadens the picture. So, she was married to Oceanus.
Okay.
I don't know. Oh, yes, and Mr. Spirit's question. Have you heard about Nicholas Fatio de Duillery's theory about gravity? Sorry.
Well, that's okay. You massacred the name, and I'm trying to put the name back together in my head. How do you spell the last name?
Deduillier. Theory, physics of gravity theory.
I don't know his theory.
Yeah, okay.
But
that was from Mr. Spirit. Can you give us a brief explanation maybe in chat? What was it about specifically? Like,
because it might be something I know by a different name. You know, that's the thing. You know, names of people's theories. I tend to think of I tend to remember the theory itself, not necessarily the person who founded it. You know, or came up with the thought. That's my little issue. I'm concerned about data, and you know, I'm excited about the data kind of a thing. So that's why. Let's see what this is.
Okay, hold on. He's known for his work on the zodiacal light problem in astronomy, known as the push or shadow theory of gravitation.
Oh, zodiacal light.
I'm doing my best here. I'm not the astronomer. I'm just allowed to hang out with him. So
if you don't want me to correct you, I won't.
I do.
Good.
So chat knows what's going on. Yes, pronounce them properly. Okay. Do you know anything about that?
I actually don't. I don't. I mean, there's certain. See, there's a number of theories out there that I've been dealing with, and I don't want you to be seeing a blank screen here, so I'm going to try and find something while we're at it. One of the things that I think is a good idea is to, you know, learn about the different types of theories that will relate to whether, you know, or how we might actually be able to leave this planet someday. And among them is there's a theory about space travel and propulsion that deals with different frequencies, and there are frequencies in the universe of different objects, and different propulsion methods would actually be achievable through the realization of using certain frequencies and matching certain frequencies, bringing certain frequencies into resonance, so to speak. And if that's true, then there's a possibility that we could travel instantly anywhere in the universe. Now, it's sort of an off-the-wall theory, but it is something that merits some investigation. Anything like that merits investigation, because it may be reaching into science we don't yet know, which I call science undiscovered, as opposed to undiscovered science. Science undiscovered is something that, you know, we see every day. You know, just like we see species that have shown up out of nowhere that we never knew existed. We have that going on too, you know, and I think that it's very important to you know, consider that maybe we are going to find that there's a lot of science that we don't yet know, that we can't explain, and that's something that we already, you know, we see now. And so moving forward, we're going to want to explore gravity far more deeply, because we don't know what gravity is. We know how to calculate it. We know its force, gmm over r squared, you know, the formula for gravity. Everybody knows that. It falls off as the square of the distance. Yeehaw. And we know all that. However, we don't know, for instance, M22 is coming back. We don't know, for instance, how gravity actually operates. We can reflect light. We can refract light. We can set the intensity of light. We can turn light on. We can turn light off. Similarly, with magnetic fields and electric fields, we can do all the same things. We cannot do a thing with gravity. We can't negate it. We can't reflect it. We can't capture it and do anything with it special. We
can make anti-gravity rooms where you float.
No, we can't. We can't change its frequency. We can't detect the wavelength, if there's any, of gravity. We can't, you know, we can't.
Wait, what do you mean? No, we can't.
We don't have anti-gravity
Well, are there not?
You talking about the parachute places that run a giant fan and blow you off the ground?
No, I thought like for like filming. I think it was in
Apollo
oh my
13?
god. Yeah, but they could only do it for like 5 seconds at a time for a shot because they just got so nauseous.
Well, actually, that's because they were riding something called the Vomit Comet, and that's an aircraft I definitely want to fly. The Vomit Comet is a large aircraft, KC-130, and it doesn't have anything. No seats are inside. It's just a padded walls and floors and ceilings, a long tube. Okay, and they fly in these parabolic maneuvers. So they go down to a deep trough, and then they go up in the sky, and then they arch over the top. As they arch over the top, the period of time from where they start to go over the top to where they finish coming over the top can last anywhere from 14 to 25 seconds or so, and in that time you're weightless. If you're laying on the ground, you'll suddenly float, and you will be weightless. You can operate just like an astronaut in space. You will feel the same thing an astronaut feels in space all the time, and that is the whole thing with the weightlessness. And for Apollo 13, they actually built a set inside the Vomit Comet, and they all went up into space. I'm sorry, all went up in the sky, and they flew endless cycles to get this, to get the shooting done. And they did. When they showed zero-G scenes in Apollo 13, where there was floating around, there were no wires. They were really doing it. They were really floating. But then again, so was the cameraman, so was the crew, so was the director, so was the lighting guy, so was the sound guy. Then it was just crazy, and they like, everybody was puking, and it was hilarious. I would have loved to have been working on that movie. I would have puked my guts out, but I would have loved it. It would have been the most fun I had, puking my guts out. I say that the most fun I ever had, getting seasick actually, was on a nuclear submarine when I went on a sub as a guest, and I went out to sea on the sub, because I had done some special work for the Navy, and they said, "Hey, you want to go for a ride?" I said, "Yeah." And when I got out there, I was like, "Wow, I am so sick." And they said, "Oh, we'll go see the doctor." "Where is he?" "He's the 18-year-old kid there over there." "Oh, that's the doctor?" "Yeah." "Oh." And then they gave me a patch called scopolamine to put on, and it totally fixed my seasickness. And I was like, that's odd. I've never seen this before. And that was in 1994. And then later on, a few years later, we saw the patch marketed. Apparently, the military gets these first. I'm looking. I'm just looking at.
I was waiting to say your seasickness went away, but so did the color in your sight or something. Or your ability to walk or something like that.
Oh, that's funny. I'm going to an object in the sky that we can see here, just so you know. Because I know that, you don't want to just stare at a black screen. We have the ability to look at something, so I'm going to show it.
Do you think, like that Vomit Comet, do you think the lack of gravity would make people hyper aware for those 15 to 25 seconds?
Don't know the answer to that question. Hyper aware? Well, I mean, they would definitely feel like they're falling, because that's the feeling the astronauts feel 24/7. You know that feeling you get when you go over the roller coaster bump and you come down the hill, boom, that feeling in your stomach? That's what you feel on the Vomit Comet. That's what astronauts feel all the time. And they have to work in that, with that feeling. They have to work through
Okay,
that.
I don't like that. I was thinking like if when you're going on a swing, when you reach the highest point forward and the highest part backwards before you start going down, or like when you're taking off on a plane, just that moment. I like that. I never thought of the come down.
It's not taking off on a plane doesn't do it, but you're right. The swing where you just
well, in
start
your
to fall
stomach,
down.
you feel that light kind of, yeah.
That's the feeling. You're right, and that's how they feel all the time. But that. Okay, by the way, this is M11, the wild duck cluster again. I figured it's available. And what's interesting is I took this picture just now. I'm going to show you something. And some of you already probably saw it in chat. Look at that. Over there, we have this little dash. Now, the time that I took this picture, and the photo is just I think 8 seconds or 5 seconds, and there's this dash. Now, in the time I took the picture, this little satellite was out there and coming through, and it took it 5 seconds to go from one end of that to the other. Let me just confirm the time, because I'm going to be talking through my butt. Yeah, 5 seconds. So, in the 5 seconds that we took this picture, okay, you can actually see that we actually ended up with a satellite on the view. Isn't that cool?
I'm so disappointed David's class had to leave.
Oh,
when I saw that, I was like, I bet that's a satellite going by. Did you know it was passing and you specifically timed it like that, or just luck?
Not at all. It's just blind dumb luck. That's what happens. You actually get lucky sometimes.
Well, it's not the first time we've seen that, so...
No, but that's because we have tens of thousands of objects out there that are, basically going to be in our view. And sometimes they're illuminated by the sun, sometimes they're not. Now, could it be that the satellite's being illuminated by the moon? Yeah, it could be, considering the time. Okay, it's 11:30, and so maybe that's actually being illuminated by the moon. Probably not, though. I mean, it could be that it's high enough so we see that it's the sun. If it was a regular satellite in that 5 seconds, it probably wouldn't have been such a short path. It would have been a much longer path if it was a lower Earth orbit satellite like we typically see. This one's pretty far up, pretty far out there, because in 5 seconds that would have been a lot longer, because look what we had to do. We had to actually zoom in a lot to get that. You can see it there on the lower right now. That's 5 seconds, and don't forget that cluster that we're looking at, that's a third the size of the full moon. So this is that's a small amount for the satellite to move in that time. So it probably wasn't a 250-mile orbit. It's probably something up in the 500 or 600 mile high orbit, and it could be that the sun was still available to it, depending on its angle. It might not be quite sunset for it. It's really cool, though, when you see a satellite go into sunset, because if you're taking pictures, you can watch the light go from whitish to yellowish to orange, and then it fades. That's beautiful.
That's awesome.
So with wild duck, and we have a satellite interloper. I'll make sure I put that up for all to see. Okay.
Do you think there are people that track satellites to try to get pictures of them going by? Yeah, I mean, nothing would happen if you tried to defocus it or do a spectral of it, because it's just an object, just an Earth object, right?
Yeah, it's reflected light from the sun, but I could tell you that.
But would it catch any particles on its travels that we could pick up, that we could see this element, or I don't know, this particle seems to stick to it and this one seems to bounce off of it, or...
Well, that's an interesting thought, but I tend to think not, unfortunately, and only if it was re-entering the Earth's atmosphere, in which case it would be, we'd be seeing the burning elements from its spectrum when it burns up, and we would be seeing, what it's actually made of, basically. Now, I am going to be experimenting with a system, hopefully before long, that will allow me to dynamically track satellites. And I will be able to actually see them, and we will be able to follow them, and that's something that's coming. Just thought I'd mention that. Now let's see.
Well, no, because I remember you saying, when we were talking about if we could get to, what was it, Alpha Centauri or maybe Proxima B or something, and going so fast and then just stopping. Obviously that's not the speed we're talking with the satellite, but it's obviously collecting things, and if it just came to a complete stop all of a sudden, I don't know. Just one of those things that I never thought about, so naturally I said it out loud.
That's okay.
Wow.
That's pretty cool. I just think that we're not actually going to be able to do much more tonight. So what I'm going to do, actually, I'm just thinking here out loud. I'm going to take us to the moon for one last hurrah. And even the moon is going to be kind of blinding. Let me just reduce the ISO here.
Your eyes.
There we go. So there we are. Now I'm going to let's drop it down. Actually, you can see clouds moving over the moon there. So I'm showing it to you this way, so you can actually see the clouds that are moving over the moon. And this might be the interesting way to end the stream, actually, as we look at the moon, because now we're going to get the opportunity to actually see. I told you about the clouds sometimes acting as a filter, remember?
Mm-hmm.
And now what we're going to see is a little bit of filtering going on the full moon. This might make it a little bit more, well...
You know what? I
like it nicer.
Well, I mean, again, I'm 30 seconds behind of what I'm seeing here, but I like how you did that, because especially on P&K space imaging, all of a sudden, it's like, where did the moon go? Why is it blacked out? And they're like, because clouds are passing by, and they're like, what are you talking about, clouds?
Yeah.
But as it got lighter and darker, as you adjusted it, that makes more sense, because you can actually see the clouds, because I don't know. I don't know why. I don't know, because it's like we're looking out in space and there's no clouds in space, not taking into the account the telescopes on Earth, and we have clouds, and that's what's, yeah. I don't know, it's just, it's...
Here we go, there's a little
just
black
a perception, right?
Yeah, for sure. But this is nice, because we're going to get a nice little filtered view of the moon, which will probably end up fading on us, and it's an appropriate cut of the music, because it's a long, drawn-out, fading music. If you can even hear it. I don't even know if people can hear it, but you know, the music helps me set my pace, by the way. So I like having music in the background. I've never done a talk or a show of any kind without having music in the background. And part of that comes from the fact that I've been a magician since I was 14 years old. So whenever I do a magic show, I would tend to use music in the background. And, you know, ambience is very important, and I want to share the ambience with all of you and make sure that you appreciate it the same way. See, that's pretty. So, my telescope has started to do up again, but I do want to thank you folks for coming out and spending the time with me that you did. We got farther tonight than I thought we would, and I'm very pleased that you were able to join me. Now, just for the record, if you actually have any questions for me, you can always leave me questions. I'll be happy to answer them for you. You know, while you're at it, share us with the world, guys. You know, tell people about us. Subscribe if you haven't. Get people to subscribe if they haven't. And make sure you tell all your friends, because SkyTour LiveStream here at John Zach Memorial Observatory is something that we do as a love. It's a passion. I don't get paid. I don't expect to get paid. I just think that it's a beautiful opportunity to share the universe above with all of you, and I hope that you really like it. I mean, it seems like you do, you know. And I really enjoy that you come and spend the time that you do. And I'm always trying to modify the settings as we're talking to try and actually get something to happen here. Like, see, I can bring it back in the moon just a little bit. You know, through the clouds. It's really dark up there. You can't even see the moon, but we're seeing it through the camera, even when it's not visible in the sky, because I'm pulling it through, you know, with the sensitivity of the camera. That's just cool. See, now you can see how much I was going up with that. So, yeah, there we go. So anyway, I do want to thank Paul and Keith from P&K Space Imaging. I want to thank Bill, New York Skywatcher, for helping, and of course you, Amanda, and other tireless mods that have been helping us. You make it happen. Without you, I couldn't do it. So I really appreciate this. Now, if it wasn't for you guys, then I'd be probably sitting around all day, wondering if I should get a life. Investing in some swampland somewhere. I don't know, but just want to thank you all. So, thank you for watching.
And Jude says, "Happy feather shredding moon per Passamaquoddy."
Oh, yeah, Passamaquoddy. My mother was a Passamaquoddy Native American.
Wasn't that the place, the town in Pete's Dragon?
I think it was actually Passamaquoddy, but that's actually the name of a native tribe. It's also the name of a native language. So, there's the Passamaquoddy language, the Passamaquoddy tribe.
Before you go, what's happy feather shredding moon? What does that mean? Are we looking at a feather shredding moon?
I don't know. I don't know what Jude means by that. But you know what? If she's still out there, she'll tell you.
Okay.
And she's probably writing it right now as we speak. Because, she's good at that. She's actually a Native American too, I mean, it seems like I'm surrounded by them, and I love it, She's a Cherokee. And like when I had my surgery a few years ago, I had a really strange experience during the surgery when my heart was stopped. And, someday I'll share all of it, but it ended up with me literally being taken out of the hospital and brought into New Mexico. And I was with my Native American ancestors, and it was just the craziest thing I've ever experienced in my life. And I'm a science guy. This stuff doesn't happen to me until it does. And then you go, whoa. So pretty cool. Pretty cool.
And I have heard that story. I suggest you hit the bell if you haven't already, because when he does tell it, you don't want to miss it.
Well, maybe they do.
No, they don't.
That's pretty. Well, thanks for that. Yeah, I'm sure that,
everyone loves Mark's stories.
Well, but it's not like it's something I could not explain at all. And I just
those are the best kind.
Yeah. I mean, it's like when I was on the submarine, I had an incident where, I was seasick, so I was trying to hide from the, anybody that might see me throw up. So I was trying to sit in the area where the sonars were working, and while I was sitting there, I was zoning out, and it felt wonderful. I could feel myself, just feeling a little better. And the kid that passed as the doctor, as I said, he gave me my scopolamine patch. Anyway, he as I sat there, I heard the sonar guy, and out of a sound, kind of dazed, dozing off kind of a thing, I heard him yell to the executive officer that he had something on the sonar. And he called it a fast mover, and I was immediately worried that that was a torpedo, because we're out in the North Atlantic, and I was only a guest. I wasn't a sailor, and I'm immediately thinking, okay, where's the emergency exit? Oh wait, there isn't any, and so the executive officer came over and he looked at the screen, and the kid, I mean, it's loud in the submarine. You can't imagine. It's not quiet. You're hearing high pressure air, you're hearing noise, everything. The pride of the Navy is that they don't let that sound out of the submarine. And so as I was sitting there and listening to the executive officer talk to the kid, he asked the kid, how fast is this thing moving? And the kid he did a double take, and he looks at the executive officer and he goes, sir, it's moving several hundred knots. And well, okay, what? Several hundred knots? There's only one torpedo that can move 200 knots, and that's Russian Skval torpedo, and it's a rocket torpedo. It's the loudest thing in the ocean. This thing was almost dead silent. And the kid said, it's not a machine anomaly, and he double-checked it by looking at the sonar next to me. And he was like, I don't know what to do. And the XO like looked really perplexed, but then he said, log it and dog it, which means obviously, well, note that it happened and then bury it. Whoa, okay. So I got up and I went over to the XO because I'm Mr. Big Man now. You know, I had a clearance. I had a fairly high clearance actually, and you know I've had that since 1995. So I went up to the guy and I said, Mr. XO, yeah, I'm familiar with these fast movers. Is there something I can help you with? And he looks at me and he smiles and he says, Mr. D'Antonio, are you having a good trip so far? Yes, sir, I am. Let's keep it that way. Okay. And he turns around and walks away. And I was sitting there like, you know, it's like, okay, so much for that. Okay. So later on, like 4 years later, I had to do a job for the Joint Chiefs of Staff. For those that don't know, I mean, I am an astronomer, yes, but I own a model making business. I've had it since it started full time in 2001, but it was part time in 1994. And I was doing a job for the Joint Chiefs, and it was classified work. And I had finished the job, and I was going to drive it down to this particular Air Admiral's house. And he was actually second in command of the Navy. So I drove it down, and again, me, Mr. Big Man, you know, going to meet the second in command of the Navy. Look at me go, you know. And I was in his living room in his house because he invited me to his home. Gave him the project, and I leaned over to him and I asked him. I said, Admiral, what can you tell me about the Fast Mover program? Because I figured, hey, this is the guy that'll know, and he'll tell me the answer. And he looked at me and he goes, I can't talk about that program, Mark. Oh. So, you know, and he's a very friendly guy. So, you know, we're friendly, actually. And he said to me, he can't talk about it. And by saying nothing, he said everything, didn't he? He admitted that it exists, but he couldn't talk about it. And I was literally stunned. I was blown away. I had driven all the way to Maryland to his house from Connecticut. And I was so excited, I wasn't even sure I could drive home because my hands were shaking at this information. So this was crazy stuff. So, I mean, that's the kind of stuff. There's a Mark story, if that's what you want to hear, as a Mark story. But that was, you know, I was just blown away by that, you know, and I was blown away by the knowledge that, you know, we have as collectively as, you know, just in the American Navy that we have of these weird things out there, but we can't ever touch them. We can't get to them. And that's, you know, that's why I'm the Mutual UFO Network's chief photo and video analyst. I've gotta, you know, I gotta investigate these things, and that's what I've been doing. You know, I joined that organization in 1971, 2 years after it started, and I've been in it ever since. And so I became the chief photo and video analyst in 2008. I mean, talk about doing your penance, right? Getting your dues or whatever, paying your dues. So it's pretty intense, you know, and there's a lot of interesting analogs and things that happen when you're doing this kind of thing, you know. So anyway, so that was a little story you probably didn't count on hearing, so I apologize if it bored you.
I like that story. I always like your stories. It involves you, I don't know. A lot of them involve you somehow getting in trouble and yet being invited back.
Hey, yeah, let me tell you, when I was a kid, I learned about chemical reactions, and don't ask me how. I don't know how I learned this. I think I learned it by a library book. I went to a library because I was a little bookworm, and I learned that if you take Drano and water and say a catalyst, something that it can operate on like metal shavings, you can get hydrogen gas. It's like, ooh, yeah, I want hydrogen. So I was going to fill these, you know, clothing bags. My father actually owned a laundry, and he had those little lightweight, you know, clothing bags, the garment bags, very, very lightweight. And what I figured was, I'm going to make hydrogen, and I'm going to fill these clothing bags, and I'm going to send these things up in the air. So it took about 5 hours to make enough hydrogen to fill a regular clothing bag, because the reaction bubbled away, and then I had the gas was coming out the bottle that it was being made in. It was a big giant water jug bottle from like a water cooler, but it was glass, and it was coming out of the water cooler bottle and going into a milk jug, a plastic milk jug full of cotton. Why? Well, because what was coming out was heavily laced with steam, and I had to get rid of the water vapor because it was heavy. So it came out of the first jug, and that still put too much water in the bag, so I made up a second jug as a second stage filter, and that filtered out the stuff, leaving me a fairly dry hydrogen gas only coming out at the back end, and that went out into the bag. And after about 5 hours, I would tie it off at the bottom. Jeez. Sorry about that low-flying airplane. No, I'm just kidding. It was a truck. I'd tie it off at the end, and then take it out into this abandoned, empty lot next to my house. And I'd let it go. And it would just start sailing up into the air, because hydrogen is the lightest thing on Earth. So it would just sail up into the air. And of course, it's also one of the most explosive. And of course, me being fascinated by the Hindenburg, I took one of my bow and arrows, and I had a little can of gasoline sitting next to me, and I would, like a coffee can of gas, and I would dip the arrow in the gasoline, light it on fire, and then shoot at the hydrogen balloon. Now that was, starting to course up there like 100 feet up, or 50 feet up, or whatever, and several times I missed, and I'd have to put out little grass fires. But when I connected, I only remember seeing this bright flash.
Oh my god.
And hearing this, and it hit me in the chest like a ton of bricks. Bam! And I'd fall down, maybe not because of the shockwave, because of the surprise. But you definitely felt the shockwave hit you, like, kaboom! Yeah! And I was like, wow, that was so cool! And of course I'd run like heck, because anytime I did that, it would rattle windows in houses around the area, and they would call the police for some reason. So I'd run and run and run. And sometimes the police would show up and find little flaming arrows and stick it into the ground, and they go, what's going on around here? So they were getting wise to me, so I had to change where I did this. So I would release it in a parking lot on a Sunday when there were no cars in the parking lot. And I remember one time I kept shooting at it, and missing. So this hydrogen balloon went all the way up into the air. I never did hit it. So it went sailing over the town of Plainville, Connecticut. And hydrogen will diffuse out of that light plastic very quickly. So it might have gotten up maybe about 1,000, maybe 2,500 feet before it would just the bag would be too heavy, and the hydrogen wouldn't have escaped enough so it could come down. But man, I had so much fun blowing these things up. It was just such a good time, and the fireball was just amazing. It was a typical fireball. If you light it, it just goes whoomp, and from underneath you see the little fireball curling up, and it's like, whoa. And of course, it looked like a nuclear weapon to me. I say, oh, a nuclear bomb, wow. But yeah, it's just, that's a little thing I did, which is a little crazy, if you ask me, but probably not the best idea, but I did it anyway. I don't know why.
That is the coolest story ever. Oh my god.
Oh.
I mean, I don't know, I was thinking that's a really cool idea. I can't believe, you thought to put, cotton balls in the milk bottles to...
Oh yeah, that was
to pick up the water, the moisture, and everything.
Yeah, that was
at no point did I ever think flaming arrows were gonna come into the picture. Wow.
Well, that's
what
why
a great story.
That's why you weren't a little boy. See, okay, boys had these mischievous bents, and so that's exactly what I did. I mean, it was really good. I mean, I had such a good time.
The little boys I knew were never that smart.
Oh no, I don't think it has to do with that, does it? I mean, it has to do more with, being
making
crazy.
Making hydrogen.
Yeah, making hydrogen was so much fun.
No,
it was great. It was great.
I don't think some of the guys I know now would know how to make hydrogen. So.
Well, I don't know.
I don't know to even have that thought and to be able to pull it off. Well, I mean, then again, not many 9-year-olds are sending off blueprints to NASA for possible ISS.
Yeah. I did that.
I mean, Well, I know that's
You
not
remember that story?
typical little boy behavior.
Yeah. And I don't, maybe people in the chat have heard about this, but
Tell him again.
okay. Well, real quick, I actually I had decided that I wanted to design a space station. So I designed a plan, and I tore little pieces of notebook paper out, and I wrote up on this plan, space station design, and I sent it to NASA. Now, you gotta understand, I was 9, and I had just gotten out of the hospital after having heart valve surgery. Now, it was a very special surgery. I was the 17th person in the country to have the surgery, but it saved my life. And what I did was, more clouds, cool on the moon. You'll see them in a sec. And when I sent it down there, I didn't really expect to hear back. I was hoping I'd hear back. And what I got back was it was about a month later. I got back my plan, and in the plan there was a box, and in the box were cloth mission patches, brochures, models, books. I mean, somebody took the time to fill this box with everything a kid could want regarding the space program. And I was astonished. And my plan was in there in a manila envelope. And I took it out. And I looked at each page. And there were little check marks on each page where this particular NASA scientist had looked at every single page. And he, in a red pen, like a teacher, he wrote these comments. He wrote, he said, carbon dioxide scrubbers, really good idea. Now, I knew that when we breathe out carbon dioxide, and it's toxic to you. It's toxic. It has to be removed from the atmosphere. So I said, carbon dioxide scrubbers, that's what we need. You know, and I didn't know how to make them, but I had just suggested that would be something we could come up with somehow. And I probably read it somewhere, in a book or whatever. Because I had probably every space book there ever was by that time, except for the ones he sent me. Well, anyway, I was astonished by that, and I read that plan over. I looked at his comments, and when he wrote, very good idea, and then he sent me a letter. And he said in the letter, I want to thank you so much for sending this. You have a tremendous number of really good ideas. I'd like to see you continue in space and be able to do something with the space program. The Manned Space Flight Center will always have a place for you. And it was signed Bert Lee, scientist at NASA. Now, Bert Lee, could have gone off into obscurity, but he didn't. Bert Lee, also known as Gentry Lee, is the head of JPL's Outer Space Directorate. That's the organization that oversees every single robotic mission in our solar system. New Horizons saw Pluto, thanks to Gentry Lee. Cassini got to Saturn, thanks to Gentry Lee. The Mars rovers are on Mars, thanks to Gentry Lee. And I actually wrote Gentry an email for the first time in like 40-something years. And I reminded him of the story. And I said, do you remember when that little kid sent you this plan, and then you sent him a box full of space stuff? And although he didn't remember, he said, that would have been like me. He says, that is exactly the kind of thing I would do. I was always trying to be very encouraging. And I said, well, you know what, Gentry? You did it because I became an astronomer. And it was all because of you.
I love that story.
Yeah.
That might be my favorite story. I mean, the Flaming Arrows was a great story, but
that's a mischief story.
I do. That touches my heart because I do. I wish he knew what you were doing now. I wish you could get hold of him now and say,
there's no reason I can't, because he said to keep in contact with him. And, we actually started conversing in email, and I have his email address. And
invite him on. I mean, you could be doing this for unlimited people. Like, he took the time to get back to one young boy, but you have the potential to reach everyone, anyone that has access to YouTube.
Yeah.
I don't know.
Well, I might do that. I know that we have um, next week sometime, and you're of course always free to join us. You know, and I would never say no to that. You can always join us. I hope you do. Next week we're going to have Bill New York Skywatcher, and we're going to have Commander Cobra from KGRA, and he'll be on with us, and he's going to join us to speak. And if it's not clear that night, we're going to make it a cloudy night stream. We'll be inside and using the simulator to show some cool things. But that'll be that's next week. Now, one thing I would love to do, I would actually love to see if I can get Gentry Lee to come on with me. You know, and I don't know if it's possible, but I'm going to try it because you know, the guy was a tremendous influence. He's the reason that I'm in this dome tonight. You know. So
I
I'm
think
hoping
we should
that,
make it happen.
I'll try. I'll give him a call. I'll write Gentry and I'll see if he'd be willing to do that. You know, I'll find the email that I wrote him and then get.
Well, I was gonna say, I wonder if I could find him, but you already talked to him still. So.
Well, I talked to him that time, yeah, and I was just astonished that you know, what he became with his knowledge base is something that everybody should aspire to. He is doing real life science exploration endeavor, and that man is you know, innovative, and he's a very good human being. He's actually managed to get us out into the cosmos quite far, you know.
You know, one of the parts I like best about that story is because you said, like, at the time when you sent in the blueprints for the ISS, he could have been an intern forced to answer every piece of mail that enters the NASA mailroom, right?
That's right.
But then you get in touch with him decades later. He probably has people now. He probably has, a building's worth of people because he's so important and so busy. He took the time and personally got back to you. It wasn't like a kind of stationary, generic letter just signed at the bottom. Like,
they were all emails, but still.
He's still,
right.
Well, yeah, but personal emails, not from a secretary or something. Like,
that's correct. There's no reason.
So he's still the same kind of person.
I did not expect a response from him.
He still takes the time all these decades later. That shows a lot of character.
It does.
Yeah.
The man's just an amazing human being. So,
awesome.
I can't say enough that how much I respect the guy for this. And he's also increased our knowledge so much. Now, yes, he's not the only one on the programs. There's a lot of scientists that have contributed their lives to getting this equipment done. One of them is a very good friend of mine, and a guy named Chuck. And Chuck is a guy who he was willing to move on. Very good friend. He worked for Lawrence Livermore Labs for many years. And Chuck should have the Nobel Prize because he saved millions of lives. Because it's a little known fact that when the Russian Chernobyl reactor melted down, the Russians couldn't solve it. They couldn't fix it. And it was going to get worse. And what was happening was the corium, the melted core from the nuclear reactor, was heading down through the concrete floor in that building where that graphite reactor was. It was already into the sub-basement, already down through the concrete, and it was going to reach the water table. And once it reached the water table, that nuclear core would have been molten and throwing radioactive steam for decades out of a hole that would have been a steam volcano, a radioactive steam volcano that would have been responsible for killing millions of people. Well, the Russians finally called for help, and Chuck went over with the team, and they built these little rovers that, first of its kind, never been done before. And he actually was pouring a special material onto the molten core using these rovers, which only lasted about 6 to 10 minutes in the heavy radiation field. The next rover would go in and drag the other one out that was dead, and then it would go in and make its dump of this special compound, and then it would die. And they would just do that. They did that for several weeks on end until the core and the nuclear corium was stabilized. This is something that no one ever heard about. It was at the time, I think it was probably a classified operation. And because of the nature of the operation, Chuck was not allowed to talk about it, and he retired, with honors, of course, from the lab. And but he saved millions of lives. And when it came time to send him off, basically he got his salary and insurance for life, which is the minimum, bottom line, minimally least you could do for someone who saved millions of lives. He also developed in Iraq, during the Iraq War, he developed something called bullet track. If you look it up, you'll find out. Okay, bullet track was a thing where, if you remember, we were having trouble with snipers that were picking off our guys over there, and whether we're supposed to be there or not. Okay, you gotta just put that out of your head. You have to just think about, okay, now that they're there, obviously we don't want to lose them. So what they did was they created a system that would actually triangulate where the sniper bullet came from, and before the sniper could load another shot, they would actually send a mortar round in and wipe him out right in the exact spot he shot from. It was 100% accurate, and it was deadly. And within weeks, you stopped hearing about the Jubas, the snipers. You didn't hear about them anymore, and the reason is because of Chuck. So he saved a lot of young kids too, So there's a lot of people out there that we owe our lives to. We owe a lot to. I'm sorry about the cloudy sky, by the way. I got the moon up there, but it's cloudy, and I can't even pull it out with this. It's so deeply embedded in the cloud now. Anyway, that said, I think I will end for tonight, because I did not expect these clouds. I was hoping we could go longer, but I'm afraid we can't. If you have any questions or comments, do let me know. Thanks, guys, for your attention, and for me prattling on about the stories. Thank you so much for tolerating me. And
everyone enjoyed your stories.
Well, I will talk to you.
They said so in chat.
Huh?
They said so in chat. I was just going to say, Bill NY Skywatcher is actually streaming live now. He's doing early coverage of the Perseids meteor shower. So
Awesome.
if you're still awake after this stream, please do go over there. I put the link in chat.
Awesome. I'm going to go over there right after I'm done.
Yay.
All right. Well, folks.
And thank you, Mark. This was incredible as always. I'm sorry about the dew and clouds, but I loved what we did get, and I love the stories.
Oh, thanks, Amanda. Thank you so much. Thank you, guys. Thanks for your diligence. Thanks for having fun with me tonight. We're a small crowd, but we're a dedicated crowd. So I will talk to you soon. And hey, if it's clear tomorrow, then maybe we can do this. But I'm anxious to do a cloudy night stream, and we're gonna do the simulator soon to show all the variety of things that you might want to do. You can think of anything you want. What would happen if Antares collided with the sun? What would happen if Antares was where the sun was? What would happen if Earth collided with Jupiter? What would happen if Jupiter collided with another Jupiter? I mean, anything you can think of, we can do it. And that'll be the next cloudy night stream. In any case, thank you guys, and I will talk to you on the SkyTour live stream next time.